A cosmic signal rewrites creation, the CMB's hidden truth. The universe stretched infinitely, a vast canvas of stars and galaxies, bathed in the faint, omnipresent glow of the cosmic microwave background, a whisper of light from the dawn of time. For decades, this CMB, a uniform hum of microwave radiation detected in every direction, had been hailed as the Big Bang's afterglow, a snapshot of a universe born 13.8 billion years ago in a searing explosion of space and time. Its discovery in 1965, a serendipitous crackle in a radio telescope, had cemented the Big Bang as cosmology's cornerstone, its blackbody spectrum and subtle ripples proof of a hot, dense origin. Yet, in the sterile glow of a modern observatory, a new discovery had emerged, a faint anomaly in the CMB's patterns, a signal that defied the predictions of a singular creation. This revelation, pulsing through data screens, suggested the CMB might not be the relic of a Big Bang, but something stranger, a local echo or a reprocessed whisper from galaxies, threatening to unravel the story of the universe's birth. The CMB had long been a cosmic Rosetta Stone, its uniformity a testament to a universe that began as a hot, opaque plasma, cooling over 380,000 years until light could travel freely. Its temperature, a frigid 2.73 Kelvin, matched predictions made in the 1940s by theorists like Ralph Alpher and George Gamow, who envisioned a primeval fireball stretched by expansion into the microwave realm. Telescopes like COBE, WMAP, and Planck had mapped its faint fluctuations, revealing seeds of galaxies and confirming inflation, a fleeting exponential growth, moments after the Big Bang. Yet the new discovery, captured by a next-generation observatory, revealed something unsettling: irregularities in the CMB's spectrum or polarization that hinted at a non-primordial origin. Perhaps the signal was not from a distant surface of last scattering, but a local phenomenon, radiation reprocessed by galactic dust or stars, casting doubt on the Big Bang's foundational evidence. The anomaly's implications were seismic, shaking the edifice of modern cosmology. If the CMB were not a relic of the Big Bang, the universe's timeline, its expansion, redshift ladder, and the need for dark matter and dark energy could collapse. The Big Bang model relied on the CMB as a snapshot of a universe at 3,000 Kelvin, redshifted by expansion to its current state. A local origin would imply the radiation was a foreground, like fog obscuring the cosmic past, forcing a re-evaluation of how galaxies formed and how far light had traveled. Alternative theories, once dismissed, gained traction. A cyclic universe where collapses and rebounds left residual radiation, or a steady-state cosmos where starlight transformed into microwaves over eons. These models, long overshadowed by the Big Bang's triumph, whispered of a universe without a beginning, its CMB a product of processes still unfolding. The challenges of validating this discovery were immense, like chasing shadows in the cosmic dark. The observatory's data, collected from a remote Antarctic station, showed deviations in the CMB's expected isotropy, or blackbody curve, perhaps a faint distortion in its polarization, or an excess signal tied to galactic emissions. Scientists scrutinized the findings, wary of instrumental errors or contamination, from foregrounds like the Milky Way's dust. Supercomputers hummed, modeling scenarios where the CMB could arise from local sources, but the calculations strained against decades of evidence. The Big Bang's predictions, from the CMB's temperature to its tiny fluctuations, had been confirmed with exquisite precision by missions like Planck. To challenge this required extraordinary evidence: new telescopes, deeper surveys, or probes to detect gravitational waves that might distinguish a primordial CMB from a galactic mirage. The societal weight of this anomaly was as profound as its scientific stake. The Big Bang model, woven into textbooks and popular imagination, had shaped humanity's view of a universe with a definite start, its story a linear march from chaos to galaxies. News of the CMB's potential misinterpretation spread, igniting public fascination and unease. The idea that the universe might not have a singular origin, but instead cycle endlessly or exist eternally, stirred existential questions. Philosophers debated a cosmos without a beginning, while artists envisioned skies alive with reprocessed starlight. The anomaly, though technical, became a cultural lightning rod, challenging humanity to confront a universe that might not align with its cherished narratives. Observatories, once quiet sanctuaries, buzzed with anticipation, their screens glowing with data that could rewrite the cosmos. The discovery, still in its infancy, was a call to adventure, a challenge to see the universe anew. The CMB, once a pillar of certainty, had become a mystery, its faint glow a question mark etched across the sky. Was it truly the Big Bang's echo, or a signal born closer to home, a reflection of galaxies weaving their own cosmic tale? The observatory, its antennas trained on the heavens, stood as humanity's outpost in this quest, its data a thread pulling at the fabric of reality. As scientists pored over the anomaly, the universe waited, its secrets hidden in the microwave hum that filled the void, daring humanity to unravel a story that might not begin with a bang, but with something far stranger. A cosmos in question, humanity's struggle with the CMB enigma. The cosmic microwave background, a faint hum of radiation that bathed the universe in an ancient glow, had long stood as the Big Bang's unshakable signature, its uniform whisper a testament to a universe born in fire, 13.8 billion years ago. Yet, in the sterile confines of an Antarctic observatory, a new discovery had cast a shadow over this certainty, a subtle distortion in the CMB's patterns, a signal that hinted at origins not in a primordial inferno, but in the mundane workings of galaxies or stars. The anomaly, pulsing through data screens, suggested the CMB might be a local mirage, reprocessed light from cosmic dust or stellar furnaces, unraveling the Big Bang's foundational evidence. Scientists, their minds racing with doubt and possibility, rallied to confront this enigma, while the world beyond their labs grappled with a cosmos that no longer seemed to have a clear beginning. The universe, once a story of singular creation, had become a puzzle, its oldest light a question that demanded answers. The scientific community, anchored for decades by the Big Bang's elegant framework, found itself fractured by the CMB's anomaly. The discovery, perhaps a deviation in the CMB's blackbody spectrum, an unexpected polarization twist, or an excess signal tied to galactic emissions, challenged the model that had unified cosmology since the 1960s. In observatories perched on frozen plateaus or orbiting in space, researchers pored over the data, their instruments straining to confirm the signal's reality. Some clung to the Big Bang, proposing that the anomaly was a foreground effect, dust or gas in the Milky Way scattering microwaves to mimic a cosmic signal. Others, emboldened by the findings, explored radical alternatives, a cyclic universe where radiation lingered from a prior collapse, or a steady-state cosmos where starlight slowly transformed into the CMB's hum. Each theory, tested against the observatory's relentless data, was a spark in a firestorm of debate, pushing science to question its deepest assumptions. The challenges of unraveling this mystery were as vast as the cosmos itself. The CMB, mapped with exquisite precision by missions like Planck, was a delicate signal, easily masked by galactic noise or instrumental quirks. The anomaly, whether a spectral distortion or a polarization anomaly, required painstaking analysis to rule out contamination. Scientists deployed new telescopes, their antennas tuned to finer wavelengths, seeking to isolate the signal's source. Supercomputers, their circuits alive with simulations, modeled scenarios where the CMB could arise from local processes, perhaps dust clouds heated by stars, or synchrotron radiation from galactic jets. Yet, these explanations strained against the CMB's uniformity, a hallmark of its primordial origin. The task was like deciphering a whisper in a storm, each datum a clue in a cosmic riddle that threatened to upend the story of creation. Beyond the observatories, the anomaly's ripples reshape society's view of the universe. The Big Bang, a narrative etched into textbooks in popular culture, had given humanity a sense of cosmic origin, a moment when time and space began. News of the CMB's potential misinterpretation spread like wildfire, igniting fascination and unease across the globe. Public forums buzzed with speculation, from philosophers pondering a cosmos without a start to enthusiasts debating cyclic models on digital platforms. The Anomaly's images, visualized as swirling patterns of microwave light, became cultural icons, projected onto city skylines and shared in virtual spaces. Schools adapted, teaching students to question the Big Bang's certainty, their lessons infused with the observatory's haunting data. The discovery, though arcane, had become a mirror, reflecting humanity's curiosity and its fear of a universe that might defy its need for beginnings. The cultural impact was a tidal wave, weaving the CMB's enigma into humanity's collective imagination. Museums unveiled exhibits of the anomaly, their holographic displays drawing crowds who marveled at the universe's oldest light, now a source of doubt. Artists, inspired by the data, crafted works that captured the tension of a cosmos in flux. Paintings of swirling microwave patterns, sculptures of collapsing universes. Writers penned tales of explorers seeking the CMB's true source, their stories blending science with existential wonder. Religious leaders, grappling with the implications, spoke of a creation more complex than scripture, their words seeking harmony with a universe that might cycle or endure eternally. The anomaly, amplified through media, became a touchstone, uniting humanity in a shared quest to understand a cosmos that no longer fit its cherished narrative. The scientific endeavor, fueled by the observatory's findings, became a crucible for innovation. New missions were proposed, with telescopes designed to probe the CMB's polarization at unprecedented depths, seeking clues to its origin. Collaborations spanned continents, with physicists and astronomers uniting to test theories of a cyclic or steady-state cosmos. Funding surged for experiments once deemed fringe, detectors for gravitational waves from a pre-Big Bang era, or sensors to map galactic dust with precision. The observatory, its antennas trained on the heavens, had become a catalyst, its anomaly a spark that ignited a new era of exploration. The CMB, once a symbol of certainty, was now a challenge, daring humanity to see the universe not as a product of a single bang, but as a tapestry of processes, its light a story still being written, a cosmos reimagined, humanity's legacy in an unbound universe. The cosmic microwave background, once the unassailable echo of a Big Bang that birthed the universe 13.8 billion years ago, had become a riddle etched in the sky, its faint glow now a source of doubt rather than certainty. Decades after an Antarctic observatory first detected a subtle anomaly, a distortion in the CMB's patterns hinting at a local or reprocessed origin, humanity stood transformed, no longer tethered to a singular cosmic origin, but poised to embrace a universe of endless possibilities. The discovery, suggesting the CMB might arise from galactic dust or stellar processes rather than a primordial fireball, had sparked a revolution, its implications rippling through science, culture, and exploration. Observatories, their antennas piercing the heavens, had become humanity's outposts in a quest to redefine creation, their data a beacon guiding a species toward a cosmos that might cycle, endure, or exist without a beginning. The CMB's enigma, once a threat to the Big Bang, now stood as a promise, calling humanity to forge a legacy in an unbound universe. The scientific legacy of the anomaly was a renaissance that reshaped cosmology's foundations. The Big Bang model, once a monolith, had given way to a tapestry of theories, cyclic universes where collapses and rebounds left residual radiation, steady-state models where starlight morphed into microwaves, or even exotic frameworks where the CMB was a projection from a higher dimensional reality. Research outposts, from Earth's frozen poles to lunar craters, buzzed with activity, their telescopes probing the CMB's polarization and spectrum for clues to its true source. New missions launched probes to map galactic dust clouds, seeking to confirm whether local emissions could mimic a cosmic signal. These efforts birthed technological marvels, sensors that detected subtlest gravitational ripples, quantum processors modeling alternative cosmologies, and propulsion systems for interstellar voyages to test the universe's structure. The anomaly, once a scientific outlier, had become a guide, pointing humanity toward a cosmos where creation was not a moment, but a process. The challenges of this new era were as vast as the stars themselves. Confirming the CMB's origin required instruments beyond current limits, capable of distinguishing a primordial signal from galactic noise across vast distances. Probes, their hulls gleaming in the void, faced risks of interference from cosmic rays or dust, their data vulnerable to misinterpretation. The energy demands were immense, with fusion reactors powering observatories that scanned the heavens day and night. Scientists grappled with conceptual barriers too. Accepting a universe without a singular start demanded a leap beyond the Big Bang's linear narrative, embracing models where time looped or stretched infinitely. The anomalies data, though compelling, was a puzzle with gaps, each observation a fragment of a story that required new physics to complete. Yet these challenges fueled innovation, transforming cosmology into a frontier where humanity's curiosity burned brighter than ever. Society, reshaped by the CMB's mystery, had woven the anomaly into its cultural fabric. Cities glowed with holographic displays of the CMB's swirling patterns, their microwave light a symbol of a cosmos in flux. Art evolved, with sculptors crafting works that mimicked the interplay of galactic dust and ancient radiation, their forms shimmering in public squares. Literature spun tales of explorers seeking the CMB's source, their sagas blending science with existential wonder. Education systems taught a new cosmology where children learned of a universe that might cycle or endure eternally, their minds open to possibilities beyond a single creation. The anomaly, once a scientific curiosity, had become a cultural beacon, uniting humanity in a shared quest to understand a cosmos that defied its need for origins. Public fascination drove funding for space exploration, with collectives supporting missions to probe the universe's deepest secrets. The cosmic role of the discovery positioned humanity as a species ready to transcend its planet-bound roots. Observatories on Mars, Europa, and beyond became hubs for studying the CMB, their data guiding plans for interstellar missions to regions where similar signals might exist. Ships, powered by advanced propulsion, ventured to nearby stars, seeking systems where dust or radiation could mimic the CMB's glow. The solar system's resources, helium from Jupiter, metals from asteroids, sustained these ambitions, with comet cities and lunar bases serving as launch pads for deeper exploration. The anomaly had sparked a galactic vision, transforming humanity into a civilization that saw the universe not as a product of a single event, but as a dynamic system, its CMB a reflection of ongoing processes. The discovery, glowing in the cosmic dark, was a waypoint, guiding humanity toward a future among the stars. The ultimate legacy of the CMB anomaly was a new humanity, one that embraced the uncertainty of a cosmos without a clear beginning. The observatories, their antennas trained on the heavens, had redefined reality, their data illuminating a universe where the CMB was not a relic but a living signal, shaped by galaxies or cycles yet to be understood. As humanity looked to the stars, it saw not just light, but possibility, a chance to explore a cosmos that might loop, endure, or exist in ways that defied comprehension. The anomaly, with its challenge to the Big Bang, was not just a mystery, but an invitation, calling humanity to cross the boundaries of time and creation, to forge a destiny that echoed across an unbound universe. The CMB, once a symbol of a singular past, had become a promise, a whisper of a cosmos that humanity was only beginning to know.